Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 12 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice strong glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweetener, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this series of video lessons, and in these lessons, I will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Hopefully, most of you guys already have your gear. If you don't have your gear, look down in the description. There is a link over to Amazon where you can pick up one of these kits. And believe me, your life and my life are going to be a lot easier if we are working on identical hardware. But enough of this shameless advertising. Let's jump in and talk about what I am going to teach you today. And what I'm going to show you is I'm actually going to show you my solution to the homework assignment that I gave you in lesson number 11. What was that homework assignment? You were to take your RGB LED, you were to connect it to 3 different buttons, and if you press the red button, the LED is supposed to turn on red. Press red again, the RGB LED will turn off. If you press the green button, the LED turns green. If you press it again, it goes off. If you press the blue button, the LED turns blue. Press it again and it goes off. And so it was to control the color of the LED using your 3 push buttons. How many of you were successful? If you were successful, leave a comment down below. I am legend, double chest bump. If you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully most of you guys were successful because there wasn't really anything really new. It was just a practice to bring together things that you had learned in earlier lessons, bring them all together into the same program and do something that is pretty cool. So enough of this nonsense introductory banter. Let's jump in and let's see if we can get this project done. And so what we are going to do is come over to this view, which I think is a pretty good view. It would be an even better view if I got out of your way. And what I've done here, I left our RGB LED circuit hooked up from last week. And remember, the long leg is ground. It comes down to the ground rail. And then I actually established that as ground rail through this black wire, which goes to pin 39, the lower left pin of the Raspberry Pi, which is a ground pin. Then I have 3 current limiting resistors, one for the red leg, one for the green leg, one for the blue leg, and then the red portion of the LED, the red pin, is controlled from pin 37. The G is controlled from pin 35, and the B is controlled from 33. So we've got ground is 39, then red is 37, green is 35, and blue is 33. All that was done last week. It is shown in the schematic up here, so I went through that pretty quickly. Now what you need to do is you need to get your 3 colored buttons. And so to do that, we will go to our most excellent kit. We will also go to our studio view here, and you can see my kit. We will open it up and look and see all of that wonderful electronic goodness in here. And it is in this big little bag of components here. Inside of here, you should find 4 large push buttons. And so I'm not talking about the little bitty push buttons, I'm talking about the bigger ones. Then in a separate bag, what you will find is the little button color covers, these little, I should show you one that you can actually see, these little button covers you will find in this separate bag, and I have already put the covers on my switches. You will need 3, and you will need the 3 little color covers, the little 3 color covers of the red cover, the green cover, and the blue cover. And so with that, then I end up with a red button, I end up with a green button, and I end up with a blue button. And let me switch back to the overhead view. Okay, in addition to those 3 buttons, you're going to need some more wires. And so make sure that you go ahead and have your wires that you are going to need. And where are my wires? Maybe I put them back in here. Let me go ahead. I wish that we had another red, another green, and another blue female to male, but I don't think we do. And so we're just going to have to use the other wires that we might have here. I had my wires here handy somewhere. I'd already gotten them out. Okay, I've got 2 there, so I'll need 1 more wire. Just give me a second here to get my gear together. And so here is 1. I always hate peeling off another one of these because I really love these wires on the ribbon. And it makes me sad to have to pull them apart. But that's what we've got to do in this case. All right, so I think that we probably have our gear that we need. We've got our 3 buttons. We've got the 3 extra wires that we need. And also, if you look up here, these little black wires that I'm using to connect to my ground plane, guys, I really love this Bojack set of jumper wires. And what they are is they're just straight wires, and those straight wires make it much easier to keep your board build cleaner. And so that's what I have here are 3 of those little jumper wires. And if you don't have one of these, I've got a link down in the description. It's like 12 bucks or something. Go ahead and pick this up because it'll allow you to keep your builds much, much cleaner. All right. Now, one thing I've got to tell you here is on these buttons, be very careful plugging those buttons in. You want to be mindful and careful about pushing those buttons in, because if you're not careful, it is really easy to bend those little pins. It's very easy to bend those little pins as you put them in. And also remember that the pins that are facing each other, those need to straddle that center trench in your breadboard. So it does matter when you put these in, you know, putting them in. I'll show you. You see how I've got those, I've got the pins that are pointing towards each other. Let me show you. You see the pins that are pointing towards each other here? Those need to straddle that center trench. And so putting them in this way is correct. Putting them in that way, it probably isn't going to match and plug in. You're going to bend the pins and it won't work. So you've got to put it in with those pins pointing each other, straddling the trench. Okay, so we've got that. And now try to use your thumbnails and press on opposite corners at the same time so you get all 4 of those pins all the way in there. So I've got red. Now I'm going to go for green. Same things. Those pins pointing towards each other, straddling the trench, pressing with fingernails on opposite ends, coming in and getting the other ends in, and then we're going to have blue. All right, same thing. I'm going to get it over the trench, pressed in, press on the opposite corners, come back, make sure they're all in there securely. I think I have those things in there securely now. All right, now the first thing I think I'm going to do is just come in and put my ground wires in. And so I will start here with the ground on the red, jump down to the ground rail, and I'm connecting these to the right leg. I'm connecting the right leg of these buttons down to my ground rail, like that. And then I should have one more of those little, where did that little wire go? I guess I'll get another one out here. Oh, there it is. It fell down in the trench. I knew I had it. Okay. And now the blue button, right leg of the blue button is connected to the ground rail. So I've got all 3 of these buttons grounded. Now, one thing you're going to notice as I go through both the circuit build and as I go through the coding, I always do things in the same order, RGB, red, green, blue. So if we look at my channels here, the left one is red, and then we've got the ground, and then green, and then blue. And then the buttons, red, green, blue. And then when I hooked up over here, remember, pin 39 was ground, and then 37 is red, 35 is green, and then 33 is blue. I like to do things red, green, blue in order. And when I jump in and start coding and start doing things, you're going to see if you do it methodically and in the same order, it makes it a little bit easier to keep track of things. Okay, now if you look up here, now I need to put the control pins or the GPIO pins on these buttons up to my LED. And you can see the red button is on the left. The red button is on the left, and it looks like it goes to pin, and we will hop over here to our pin diagram. It goes to that GPIO pin 11, right? So we're going to go 11, 13, 15, red, green, blue, 11, 13, and 15. So we will come back over here, and I'm going to hook the wires into the Raspberry Pi first. 11, 13, 15, and then I'll hook them up to the board. So I'm going to start, I do have a red wire here, so that is going to be 11. So I go 1, 3, 5, 7, 11, and then I'm going to check that here. Yes, 11, and then I'll come back over here. So I am 1, 3, 5, 7, 11, and then my next one is 13. And you guys can hook this up easier than me because you can get the board right up in your face. And I'm having to leave it in the camera view, which means it's a little harder for me to see. And then finally, my B, my blue, is going to be my white wire. Okay, my blue is going to be my white wire. Okay, so now that looks good. And so we are going to do what? We are going to do 11, 13, and 15. And so I'm now going to come in with 11, and I'm going to take it to the left leg of my red button. I'm going to take 13 to the left leg of my green button, and I'm going to take 15 to the left leg of my blue button. I'm going to glance at my circuit to make sure I have those in the right column. That all looks like it is hooked up correctly. And so that, my friend, was pretty easy to connect. Okay, now what I think I need to do is move this up here like this, and then we're going to move over to our code view, and we're going to see if that works. Yeah, I think you can see the Pi, you can see my circuit, and you can see the code view. Okay, so I think we're ready to jump in and start coding this thing, and I should talk a little bit about what the strategy is. Press the red button once, let your finger off. The RGB LED will turn red. Press the red button again, it'll go off. Press the green button once, the LED will turn green. Press it again, it'll go off. Press the blue button once, the LED will turn blue. Press it again and it will go off. Okay, pretty simple. This is that lesson I did on the toggle switch. So what are we going to have to keep track of? For the red button, we're going to have to keep track of button state. Is it up or if it's down? If it's up and we're using internal pull-up resistors, it'll be a 1. Press it down, it'll be a 0. Let the button up, it'll be a 1. So we're looking at that transition from 0 to 1 to indicate that we should turn it on. So we're going to have 3 buttons, and we're going to have 3 control signals to the LED. And so this again will be very simple to that, similar to that toggle switch lesson we did earlier. Okay, enough of this talking. It's time to start coding. So what we're going to do is we are going to LS, and you can see that I have been hitting my screen capture. So I'm going to just take a second and remove those star.png. LS, okay, clean that up. Now what I'm going to do is I'm going to nano down. Let's see what I have down in Python. Let's just nano down in there, Python. And then what we're going to do is we're going to call this my RGB button.py like that. You can call yours whatever you want, but boom. Fresh new Python program just waiting to be written. If we are going to be working with the GPIO pins, the first thing that we are going to need to do is make sure that everything is perfectly straight. Perfectly straight. That's not good enough. That's pretty good. That needs to go up a little bit. Okay, everything is perfectly straight. Not quite. There. Okay. If we are going to be using our perfectly aligned GPIO pins, we are going to need to what? Import our old friend Mr. Uppercase R, uppercase P, little I, dot GPIO, and then import those as what? GPIO. Then we are going to from time import sleep. Okay, because we're going to need delays. We're going to go ahead and put in a delay, DT delay time. We will make that 0.1. That'll be good. Now, my LED is going to have 3 pins. I'm going to have the R pin, and that is already, we've got it over here. The red pin on the LED is connected to what? Pin 37. Pin 39 lower left is ground. The one above it is a GPIO pin. It's 37. That's the one we're using. Now G pin is going to be the one above that, which is 35. And then B pin is the one above that, which is going to be 33. You see how if I do RGB everywhere and kind of put things in order, things kind of start going quickly. Now we also have 3 buttons. So I'm going to have R button, and that was hooked to pin 11. And then the G button was hooked to the pin below that, 13, and then the B button is going to be pin 15. So those are our button pins. Now we've got to keep track of what? The button state. So for it to switch the LED, we need to go from a 0, which is the button press, to a 1. So we've got to keep track of where the button is now, and that's going to be R button state. And normally in the up position it's a 1, so we'll go ahead and just initialize that to a 1. And we need an E there probably. Okay, R button state, and then what? R but state. And then what was it last time through the loop? The old value. So this is our breadcrumb. Well, when it starts out, if it starts out at 1, then we'll just say that it was 1 before then. So we're just giving this something to start with. Okay, now if we do that, let's see if we can actually copy and paste that. I don't know if we can copy and paste that, but I will try. Okay, let's see if that will copy. Might make it a little quicker. Let's say copy, and then here. It's not copying and pasting today. So we're just going to have to type. So we're going to have the G button state is equal to 1, and then G button state old is equal to 1. Also, do you notice like it's RGB, and then be consistent in your capitalization, and you can see that I'm using the bumpy font here where like I uppercase the first letter of each new word, and usually I start things with a lowercase. So if you just kind of get into a habit, then it's very easy to sort of help you get your variable names when you're using a lot of different variables. But I digress. Now we're going to have the B but state is equal to 1, and then the B but state old is equal to 1. So R but state old, G but state old, B but state old. That all looks good, and all my capitalization looks good. So we are looking good there. So we have got our control lines set up for the LED. We have the states set up for the buttons. Okay, and now I think the other thing that we've got to do is we've got to keep track of where is our LED. Is the LED on or is the LED off? But now we kind of have 3 states for that, right? So we have the R LED. Let me get my cursor back down here. We have the R LED state, and we're going to start, the whole thing's going to start off, so the R LED state will be 0, and then the G LED state is equal to 0, and the B LED state equals 0. So not only do we need to keep track of, is the button up, is the button down, did we go from the button being down to up, we also need to keep track of where is our LED. So I'm saying right here, our LED state, I'm saying presently the red channel of the LED is off, the green channel of the LED is off, and the blue channel of the LED is off. So we've got to keep track of the state of our LED. Okay, so that is all good. Man, we're blasting through this. But it actually kind of goes fast when you're organized in the way you do things. What do we need to do now? We need to start setting up those GPIO pins. So I'm going to say GPIO set mode, and how are we doing this? We want the GPIO.board. So we're using the board numbering scheme, the physical pin numbering scheme, because that's the easiest one to use. So we're doing that. Okay, so now we've got that done. Now let's set up our output pins for the LED. So we're going to do GPIO.setup. And what are we going to set up? The R pin, GPIO.out. So that pin that's controlling the red LED is an output pin. Similarly, GPIO.setup, and that's going to be the G pin is GPIO.out. And do you see also how quickly this is going here? I don't have to remember now. Was that 39, 37? What pin was it? I'm just now going with the clean setup that I had. So GPIO.setup. I don't have to really worry about what it is. I just got to remember I named it B pin, and that's a GPIO.out like that. Boom. Okay, so we've got our output pins hooked up, or we've got our output pins all set up, and so that's good. And so now what we are going to need to do is set up our input pins from the buttons. Okay, and so now you got to remember this is the R button that I'm setting up. Got to make sure, like, don't try to write to R button and don't try to read from R pin. You got to remember which variable and which pins are going to the LED and which ones are going to the buttons, and don't get that confused, because it's really kind of when you get going here, that's pretty easy to get confused if you are not being careful. So this is going to be a GPIO.in. And then we are going to set those pull-up resistors. If you look here, we didn't put the pull-up resistors in the circuit, so we have to activate them on the Raspberry Pi. And we do that with what? Pull up down is equal to GPIO.pull up down. And I had better get out of your way before you yell at me. There you go. GPIO pull up down, and it's going to be a what? It's going to be an up like that. Okay, now GPIO dot setup, and then this is G but you see I warned you about that, and then I almost did it. GPIO dot in pull up down is equal to GPIO dot pull up down, and this will be an up too. GPIO dot set up. This is a B button, and this is GPIO dot in dot pull up down. This will be equal to a GPIO dot pull up down, and this one will be a down. Just kidding. Just kidding. It's an up too, right? Okay, so we've got those set up. So we've got all of our pins set up. Now, now I think we are ready. We are ready to get our main loop going. And so let's set up our try and accept that allow us to leave the program cleanly. And so all the real action will be happening in the try. But then when we hit a Control C, we will want to go to accept, and that will be keyboard interrupt like that. And what will we want to do there? If we hit Control C, the keyboard interrupt will take us to the accept. And there we will actually want to do a GPIO.clean up. So we clean up our mess so the pins are ready to go. And then I'm just going to say a print GPIO good to go. Why do I do that? Just to make sure that I exited the program cleanly. Now up here, what are we going to do? We are going to want to have a while loop. While true, when it's true, true. True is always true. So we have created an infinite loop here, and it will continue in this while loop until what? Until Control C, and then we'll jump down to the except keyboard interrupt. I hope that makes sense. Now, what are we going to want to do here? What we are going to want to do is we are going to want to read our 3 button states. We are going to want to read our 3 button states. So the first thing that we want to know is, have we read those buttons? And so what I'm going to do is but state. I'm going to read the button state from where? GPIO dot input, and then I'm going to read that from R pin, right? Wrong! R pin is the LED. Don't read it from the LED. You want to read it from the what? From the button. Why do I do that? Because it's a real easy mistake to make, and it's a very hard mistake to find. So that's R but state, G but state. And you see, you got to be careful with that little mistake there. Case is very important. Is equal to GPIO.input, and that's G button. We're reading the G button. And now B but state is equal to GPIO.input, and we're going to input from RGB button. All right, and now I think a great thing to do, a really great thing to do here is just to print, and then we're going to print button states like that, and then I'm going to print the R but state, the G but state, and the B but state. And in fact, I think this would be a great place to just run the program and just see, are we registering button pushes? Is everything kind of working like we think it is? So I'm going to Control X, yes, enter, and then let's go ahead and let's Python 3 the Python folder and my RGB button.py. Okay. Ooh, and what do I see? Control C to kill that. I didn't put my delay in there. So let's go ahead and clean that up, because you do want that little delay in there, because sometimes you can actually get some unexpected not goodness. So I'm going to sleep by DT, delay time, which I already set up, Control X, yes, enter. And now we are going to run it, and now it's looking better. All eyes on the red button, and it didn't read the red button. Okay, so you see I'm pressing the red button and it's not reflecting that. Now that is kind of crazy. So everything is crazy. You see, green is reading is that is insane. What did I do wrong there? I hope hopefully it's just a print statement. Okay. R button state, I read from R button. Green button state, I read from green button. Blue button state, I read from blue button. And then I print R but state, G but state, and B but state. And so you see I am reading these things wrong, like my pins are set up wrong. So I need to come back over here, and I got to ask myself, did I hook those pins up wrong, because they were reading wrong? So let's come back over here and let's look. I want to be on pin 11, 13, and 15. So I'm going to look very carefully, and this is pin 1, 3, 5, 7, 9, and I had that hooked to a ground. So all of these are off by 1. So 1, 3, 7, 9. I want to go to 11, and I hooked it to 9. So 1, 3, 5, 7, 9, 11. And like I say, I can't see those pins well because they're not right in front of me, but I'm going to check 1, 3, 5, 7, 9, 11. So that this time is in fact hooked to pin 11. And so now I'm going to come over here and I am going to come back and I'm going to Control X, and now I'm going to enter, and now okay, and so now I'm going to Python 3. Okay, so now I come over here, boom, look at that, green, blue. Okay, now guys, you see, I didn't make that mistake on purpose, but do you see how easy it was to find because I didn't have the LED or I didn't have any of that nonsense on there? And why that LED is red right now is a mystery, and it's a mystery that bothers me. And I think probably I was playing around with this a second ago before I made the video, and I probably had left that channel on. And so let's just see if we can clean that up really quickly. Let me come back over here to a more meaningful view. Okay, I guess maybe you didn't see what I was doing. So here I got, you see that, green, and blue. So you see the buttons are working. And so it was very easy for me to debug it was very easy for me to debug because I ran it quickly before I was fooling with anything else. And so just run your program as you're going along. And then clearly I had a very limited area that my error could have been in. But what you see is that LED turned red. And what I suspect is I was playing around with things and I'd left that channel on in an older program. And so I want to go in, and it's funny, even though I am cleaning up, like let's just run it again. Okay, it turned off. Okay, but you see that channel seems to be left on in an unexpected way. And so let's go in here, and just up here at the top, I'm going to turn it off. Okay, so I'm going to do a GPIO, and then what I'm going to do is I'm going to do an output, and then what do I want to output to the red pin? And I want to set it 0. Excuse me. Okay, so we're going to do a Control X, yes, enter. And now we will run it, and it came on again. Our pin, okay, yeah. I misspelled it. So this should turn that pin off. And now we are going to run it. Okay, so that turned it off, right? So now I'm going to Control C, and then I'm going to nano it. Now I should be able to take that out. Control X, yes, enter. Python 3. Okay, and the LED is off. Okay, do you see how these GPIO pins can behave a little unexpectedly? What I'm doing here in front of you and what I'm doing with this program is affected by something I'd done earlier. And somehow, even though I'd cleaned those pins up, the fact that I'd left that pin on from an earlier program, it came back on even after a new fresh setup. Now, I would say that is unexpected. But now let's look at red button state. It goes to 0 and then back to 1. Green button state, 0, back to 1. Blue button state, 0 and back to 1. And everything looks really good there. So I'll Control C, enter. And now let's go back and let's see if we can get the rest of this program written. So the good news is I'm reading the buttons. The buttons are behaving well. I printed out their states, and now what do I need to do? I need to say if r but state. I want to know, should I switch my LED? Well, let's check the red ones first. If r button state is equal what? That means it's up. And if last time through r but state. We got to check our what? Our breadcrumb. If the last time through it was 0, if it went from 0 the last time to 1 this time, what? That is a transition that we want to register. And then I'm going to go ahead and print red channel registered. I'm just putting this to see, yeah, I got into this loop, because what if the red LED doesn't turn on? Well, did I at least get into the red if statement? So this is just going to be kind of a help here. But then what I want to do is, if I get in here, what do I want to do? Well, if the LED was on, I want to turn it off. If the LED was off, I want to turn it on. So what I'm going to do is I'm going to say our LED state is going to be equal to the red LED state is going to be equal to the not of the red LED state. And so that means if it was a 0, it'll be a 1. If it was a 1, it'll be a 0. So I will switch my red LED state. And now I need to GPIO dot output that, and I need to GPIO output that to the red button, right? Wrong. Not to the red button, but to the what? To the red pin. And what do I write to it? Our LED state, like that. Okay. And so that should switch it. That should switch it. Now that should be ready to go on the red LED, but we do need to what? We need to drop our breadcrumbs. So R but state old. My R but state old is going to be equal to R but state. And since I know I'm going to be adding the other channels, let's go ahead and fix them. G but state old is equal to G is equal to G. Don't forget your D, spelling is important. G but state, and then B but state old is equal to B but state. Okay, do you see how naming my variables consistently, how quickly you can go? And also it helps you find errors, because remember how it didn't actually get my D here? And how did I see that there was an error? Because the variables were offset. I made a mistake. I missed the G. Okay, so you see this is actually pretty good. And then I see here that I made that mistake. Doesn't count as a mistake if you catch it before you run it, okay? Okay, this is pretty exciting. Let's Control X, yes, enter. And now we are going to run this thing. Okay, I'm going to need everyone to hold their breath as I bring my finger in, and we're going to press it. And now hold your breath. Shazam! Who's the magic man? I'm your magic man. Look at that. Now let's see if we do it again. It turned off. Red LED on, red LED off. Okay, that is super cool. So let's Control C. Now the rest of this should go pretty quickly, but we want to be careful so we don't just start making crazy mistakes as we go through here. But we did that. Now we need 2 more if statements, and I desperately wish my copy and paste worked, but my copy and paste decided not to work today. Okay. Now I'm going to say if what? If G but state equal 1 and G but state old equal 0, then what do we want to do? Well, we want to print green channel registered. Okay. And then what do we want to do? We want to say G LED state equal not G LED state. Okay, and now we want to write that GPIO Man, it's even getting no matter how small I get. You guys are not seeing it. Okay, there. That'll work, right? Okay. So GLED state is not GLED state. And then what we're going to do is a GPIO.output, and then where we're going to output to the G pin, and then GLED state like that. Okay. Now one more. If B but state equal 1 and B but state equal 0, then what happens? Well, we're going to print blue channel registered like that, and then BLED state equal not BLED state. And then what do we want to do? We want to write it, and that's going to be GPIO.output to the B pin, and then BLED state. You see, I can't tell you how important it is to name your variables where they're meaningful and relevant and sort of in a consistent and organized fashion, because you see how quickly I'm programming here without really having to think, because I set things up with consistent variable names to start out with. Now, probably there's like 50 mistakes in here that I made. But I think GLED state, GLED state, GPIO pin, GLED state, BLED state, B pin. Yeah, all that looks pretty good. All that looks pretty good. Okay, so let's Control X, yes, enter. And now the moment of truth. Ah, what is not defined? G but state. Oh, what is this nonsense not defined? G but state. Oh, that sure looks right. So let's go in, let's nano it. G. Ooh, you see error all the way up here. Did you guys catch that? That is where the mistake was. That's why it wasn't defined, because I misspelled it the first time through. So Control X, yes, enter. And now we're going to go up Python 3 this baby, and button state. Okay, now the red should work. I think that it would be more dramatic if I were a little bit larger. Okay, there. I think it's a little more dramatic so you can get all my facial expressions. Okay, this one should work. The red LED is on. Okay. Red LED is off. Oh, you want what? I'm sorry. You want to see the LED what? Green? Okay, we come in. Hold your breath. Don't. Shazam! Green. Look at that. I press the red button. It turns red. I press the green button. It turns green. Okay. And now we'll come in. Green off. Okay. Now what? I'm sorry. You said what? You want me to press the blue button? Hold your breath. Oh, we have problems. Okay, it's being registered. Okay, now what do we see? It's seeing the blue channel change. It's seeing the blue button being pressed, but it's not getting down into, that if statement, because it didn't say blue channel registered, right? It did not get in there because it didn't say blue channel registered. So if B but state is 1, which we know is right, and B but state old. What did we forget? We forgot the what? We forgot the old. Did you guys catch that? I think that's the mistake. Okay, so now we're going to run it. Okay, so on, off, green, and off. Hold your breath. blue. Look at that. Is that not beautiful? A blue LED. And believe me, it's much more beautiful in person than it is when you're looking at it, than it is when you are looking at it through the camera. Again, that studio camera just doesn't capture those LED colors very well. But now I'm very confident that it is going to turn off. Look at that. Okay, now that's what I did. Now, if you guys are thinking there's something that you would ask me to do right now, there's kind of a crazy thing that you would ask me to do right now. Tell me the crazy thing that you would ask me to do right now. What? Did somebody say turn on red? Okay, red is on. Now, what's the crazy thing that you might ask me to do? The crazy, insane thing that you might ask me to do is turn the green on without turning the red off. What would happen? Do we produce smoke or do we get something interesting? So let's see here. Let's see here. I come in and boom, look at that. What is happening here is, and you can't see it very well on this, but what is happening is the LED is now orange. Now I can turn the red off and it goes green. I can turn the red back on and it goes orange. Okay, now what I can do is I can turn the green off and it's left red. Now if I have red and I turn blue on, I get what? I get purple. I get purple. Okay, well let's turn the red off. And let's see, that turned the blue off. That was strange. My blue has a problem. So let me turn this off. Okay, so blue has got a little bit of a circuit problem there. I don't like these little resistors. It's like they sometimes don't go in good. So let's see. So blue button, blue channel is registered. Okay, there it is. Okay, what it is that little resistor isn't making a really good connection. Okay, so now I got the blue working. So blue is off, blue is on. Okay, so I go red on and I go blue on and I get purple. And then red off, I'm left with blue. And now if I have blue and green, I get a beautiful turquoise aqua. Okay, so do you see, you can run more than one channel at once and you start mixing. And so let's look at this. What I can get is I can get red, I can get green, and I can get blue. Or red and green makes sort of an orange yellow. Okay, so I can get yellow, red, and blue make purple or sort of a magenta. Okay, and then green and blue make aqua. Okay, actually what those are making is red, green, blue, and then the complementary color space of cyan, okay, cyan, magenta, and yellow. Okay, so you see we can make the complementary color space by mixing those things. All right. Are you guys really going to make me tell you what your homework assignment is? Or do you guys already know what your homework assignment is? Tell me, what is your homework assignment? With this circuit, what is the next really, really cool thing that we could do? What is the next really, really cool thing that we could do? We could mix the colors to create any color. Right now, red is what? On or off. Green is what? On or off. Blue is what? On or off, which allows 6 different possible combinations. Well, okay, I will admit there's one other one that we'll go ahead and do that just might be kind of interesting. But what I could do is I could let's see. Okay, I could turn on red, and I could turn on green, and I could turn on blue. I could turn on red and green and blue. Red plus green plus blue is what? It's white. And if I turn red off, green off, and blue off, then it's black. It's all off. Okay. Now, what would be really, really, really interesting, instead of having those colors on and off, is what? If I made red dimmable, if I made green dimmable, and if I made blue dimmable. And in that case, I could mix any red that I wanted with any green that I wanted with any blue that I wanted. And in that case, I could create what? I could create any color, because all colors are just mixtures of red and green and blue. So I could create the entire rainbow. Now, if you think about it, we've already done dimmable LEDs, but I don't want you to have to come in and have 6 buttons. And so what I think that we could do is on the red could just go from very dim, like, you know, from 0 up to 100, but you can't use 100, so 99. So you could go from 0 to 99 on the red, from 0 to 99 on the green, and from 0 to 99 on the blue. But don't add 3 more buttons to bring it back down. Just cycle back around. So on red, you could go up, 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 up. And when you get to 99, just come back to 0. And that way, with one button, you can get any red value. If you want to go down, you just got to go back around, if that makes sense. I think that would be easier than trying to deal with 6 buttons. What do you think? Does that make sense? So you would basically have 3 buttons that just go from down to up and then circle back around. And then you should be able to get any color in the rainbow. Does that sound pretty cool? I think that is pretty cool. Man, guys, I hope you are having as much fun taking these lessons as I am making them. I am really having a lot of fun. I've done kind of like a couple of classes on, like, just where I'm teaching Python, or I'm teaching artificial intelligence, or I'm teaching OpenCV. I am really excited to get back and start playing with hardware again. A lot of you guys have taken my Arduino series of classes, and that I just love those lessons because we were playing with hardware. And now, once again, on the Raspberry Pi, we're playing a lot with hardware. And I think it's kind of important, because most of the Raspberry Pi lessons that I see, they're just like retro gaming or making network storage devices or routers or things like that. And I think it's really neat to go in and start working with circuits and components and really banging on those GPIO pins. Okay, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. If you're not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. And it's really an encouragement when you guys support me in that way. You can also support me by giving a thumbs up to this video. If you give a thumbs up and leave a comment, that helps me with the old YouTube juice, and YouTube will offer this video to more people. And that's important, because the world needs more people who are doing engineering and programming, and fewer people sitting around watching silly cat videos. Paul McWhorter with TalkTechBoy.com. I will talk to you guys later.